We have already discussed the difference between sidereal day and solar day. Similarly, there are different definitions of months and years. Let us start with months. Civil month, as we call it, typically month which appears on a calendar, and we know in the Western calendar there can be 28 days to February, 30 days to April, 31 days to July and so on. That is what we call a civil month, month on the calendar. Lunar synodic month is a technical term used for one full cycle of lunar phases, that is full moon to full moon or new moon to new moon. And this period is not 30 days, it is 29 days, 12 hours, 44 minutes, 2.9 seconds, roughly 29.53 days, slightly short, and this is important. We will come to that in some time. Then there is lunar sidereal month. Lunar sidereal month corresponds to one full cycle of moon, one full revolution of moon around earth with respect to distant stars. This is similar to the sidereal day, and you can think of synodic month similar to the solar day. For solar day you require sun to come back to the observer's meridian. Here you want new moon to new moon, so it is very similar idea, and the sidereal period is a true revolution period of moon, which is 27 days, 7 hours, 43 minutes and some 11 seconds. So roughly 27.1/3. That is the reason why all cultures have 27 nakshatras, not 30. Then there is something called lunar draconic month. It corresponds to time period between successive passages through ascending node of lunar orbit. What is ascending node? You have already seen this in another video, but I will just quickly repeat. Lunar orbit is inclined to the orbit of Earth around Sun, that is ecliptic. Lunar orbit is inclined to ecliptic by 5.3 degrees. So this orbit cuts the plane of ecliptic in 2 points. One point where the moon starts going above ecliptic, which is called ascending node. The other point where moon starts going below ecliptic, it is called descending node. So the time period from moon is at ascending node, so next time moon is back again at ascending node is called draconic month, and it is 27 days, 5 hours, 5 minutes and 35.8 seconds. Now can you guess why there is difference between this and this? If some of you might have guessed, this is because the orbit of moon is precessing. Can we use this time period to actually find period of precession of lunar nodes? Like I have said in the previous videos, if you want to try this on your own, pause the video, take few minutes, try estimating the period, and after that we can proceed further. So let us first estimate how much, by how much angle the node has precessed in one draconic month. For that, what we will do is just T sidereal minus T draconic by T draconic converted to degrees. You calculate that, you get about 1.45 degrees per draconic month is what the precession is. If it is in one draconic month 1.45 degrees, how much time it will take to do a full circle? You calculate and you realize a simple calculation is about 6766 days approximately, or roughly 18 years and 192 days. So slightly more than 18.5 years is the rough estimate of precession of lunar nodes. Similar to month, there are also different definitions for the word year. First, tropical or solar year is just one cycle of full cycle of seasons. So, start of the spring to next start of the spring. So, time between two successive passages of sun through the vernal equinox point is, which means the same thing, and this is 365 days, 5 hours, 48 minutes, 46 seconds. Very close to 365 days and 6 hours, but not exactly equal to. Then sidereal year is the actual rotation revolution period of Earth around Sun. That is with respect to distant stars completing one full circle. It is 365 days, 6 hours, 9 minutes, 10 seconds. Why there is difference between the two? Because Earth's axis is precessing. Hence, by the time Earth completes one full circle around Sun, the vernal equinox point has changed the position. Now, you can estimate rate of precession, similar calculation what we did just now, rate of precession of the Earth's axis by taking this difference. I will leave that calculation to you. Then, for mathematical purpose, we also define something called Gaussian year. What is Gaussian year? If you keep a star of exactly one solar mass at the exact focal point of the orbit, and Earth is just test mass, and the semi-major axis is exactly 1 AU, then what is the period that you will get? Now, you know that if you take Sun and Earth, their actual masses, you will get a slightly reduced mass which is not equal to one solar mass, and as Sun is producing energy, there is also small change in mass year after year. So, for all these things we can ignore when we do the pure mathematical form, which is Gaussian year, and that comes out to be 365 days, 6 hours, 9 minutes, 56 seconds, which is very close to the sidereal year. There is also anomalistic year. Anomalistic year is a time period between two successive passages through the perihelion point. That is, Earth was at perihelion point, you start counting. When Earth comes back to perihelion point, you stop counting. Why it is different from all these previous things? Because the Earth's orbit itself is turning. So, perihelion point changes the position, and that period is 365 days, 6 hours, 13 minutes, 53 seconds. Lastly, Besselian year is defined as a year which starts from the instance when mean sun is exactly 80 degrees before the vernal equinox point, and that is the start corresponding to 1st January. So, this is roughly for 80 degrees before vernal equinox is your 1st January position. Now, you would realize by this definition of months and year that a lunar month is 29.53 days. So, 12 lunar months, if you multiply by 12, 29.5, just take a simple thing. If you take 29.5 multiplied by 12, you get 354 days. Whereas, cycle of seasons is 365 days, 5 hours, 48 minutes, 46 seconds. So, there is a mismatch of 11 days and few hours between the two. So, if for some reason on the start of your solar year, there was also a start of lunar month, and we say, okay, it's very nice, year is also starting, month is also starting, perfect synchronization. After 12 months, 13 months would start, but year would not have ended. After 11 days, year would end and new year will start, but that time we will be somewhere in the middle of month. So, the synchronization won't last. What people realize that if you wait for a few years, after every 19 years there is a rough synchronization. How? You take 235 synodic months they would almost correspond to 19 full solar years. So, difference between them at the end of 19 years is just 1 hour 27 minutes. So, that is matching. So, roughly 19 solar years correspond to 235 lunar months. But if you take 12 months a year, then 19 years should have 228 months. That is, in 19 years we have 7 extra months. These 7 intercalary months are spaced at different intervals, so that it roughly remains synchronization. So, as a result of this cycle, you may realize that Tithi in Indian calendar, suppose you were born on Diwali day, let us say, in certain year. Next year on your birthday there is no Diwali, third year there is no Diwali, but on 19th year, 19th birthday, Diwali will again fall on your birthday. Again after that on 30th birthday, Diwali will fall on your birthday, and so on. That matching happens because of this Metonic cycle.